Today we're going to work through constructing a civil cell representing a median with a turn lane. The first step will be to place reference elements. The first reference element will represent a road center line. We'll expect that this line will be in our design file. We'll create that at 575 feet. Next we'll create a reference element to control the beginning position of our median. This line could represent an intersecting secondary roadway alignment or a line a designer places. We can now untoggle Accudraw. And next we want to generate another type of control line. This will actually be part of the cell, and this will be a zero offset from the reference center line. We'll work all of our cell from this point outward. This control line is needed to be sure that the direction of our center of our cell is always consistent. We'll set the offset to 1 foot just so we can better work with this line. We'll locate the start of the line by an intersect snap between the two reference points, and we'll key in a distance of 475 feet. We need to make sure we're keying in a distance, or rather a length, and not a station value. So again, 475 feet. With our control in place, next we'll want to create the edge or parallel edges of our median. We'll be offsetting them from the intersect point. We'll be using a command called civil Accudraw with an ordinate known as delta station. So we'll set a feature for our single offset partial, and we'll toggle civil Accudraw and delta station. We'll select the control line, and notice Accudraw still is not set to active, so we'll just go up and let's change the feature so we can see it a little bit better. And we'll give these elements a name of median. And now we'll activate civil Accudraw. So you can see the additional fields. With focus in delta station, we'll hit O on our keyboard and follow our prompt. We'll locate the control line and then the intersect of the two reference lines. And you can see the station and offset lines, horizontal and vertical, on our screen. We'll key into the offset field 10 feet, and we'll set a delta station of 40 feet and minus 10 feet again for our offset, and then we'll data point. This will set our beginning point of our offset line. Now the end point of the offset, we want to make sure it is not extended to the end or past the control line. So we also want to make sure we enter the distance as a length and not as a station. So it looks like 475 might be a little long, so we'll key in 450, and that seems again a little bit long. And we'll mirror, we'll say no. And let's take a look. We'll see our control line is 475. So because of our offset, 450 is just a little bit long. So we'll enter 425. And that'll make sure that we're a little short. Now, because this will be the size of our turn lane, we're going to move this offset to the opposite side. So instead of 10 feet, or rather -10, we'll key in a positive value for the offset and shift it. Now we want the opposite side of our median, so we'll use the single offset entire element command. We want to set a feature definition. You can see we have none here, so let's go up, set it in the dialog. So we'll go into linear, road, edge of pavement, and again key in the name, median, and set it to a width, and we'll set the offset to 20 feet, and data point, no mirror. And again, we just follow our prompts. And so now the next step will be to construct the offset for the median turn lane. So for this, we want to maintain maybe a 12-foot lane width. So we'll set the offset to 12 feet. And we'll use a key point snap and snap it to the beginning of our previously placed offset line. And then we can define again the length, not station, but length. So I'll define it as 150 feet and no mirror. Okay, so now we need to construct the ratio, and it's very important that to construct the ratio, that we set it off of the offset line that we previously placed. So we'll give it a name for the feature, and we're going to select the upper line because this line will not be trimmed. It seems trimming has an effect on that ratio, so we want to make sure we go off the upper line and carefully snap it using a key point snap to the back of our 150-foot offset element. We want to enter the ratio of 1 to -10, and the length, we just want to extend it down towards the first offset. So I had keyed in and locked in the value of 125. From here, we're going to trim the outer elements, and this will give us a nice 10-to-1 taper going into the median turn lane. The next step is going to be to create the nose. So we'll use a simple arc from an element. We'll set our feature definition. And we want to zoom in and select the top element, parallel edge of the median, snap it to the end, and we'll key in a radius of 12 feet, accept it by data point, and then we'll key in a length, and we'll just enter a length of 10 feet and trim back. Even though we're snapped, the trim won't have any effect, I suppose. But now we'll do an arc between elements, and we'll key in a radius of 3 feet, selecting the previous arc. You see what happens if we enter a value such as 4 feet, the geometry can't be constructed, so we get those red dashed lines. But a radius of 3 feet, we're good. Trim and extend we'll set to both. Next, we'll create a complex element from all the linear segments we've previously placed. We'll give it a name of median line, and we'll use a different feature type, and we'll complex that together. Now we can see all our parametric constraints, and at this time we can group this into a civil cell to test it. So it's always a good idea, once you're horizontal or at various stages are completed, to test the cell. So we give it a name, give it a brief description because we'll be dropping this. So we key in a different reference name for the second reference. And you'll notice all our elements highlight, and this indicates we have positive connectivity. So one way to place a cell is to attach it as a reference file in a drawing where we want to try it out. So this way we don't have to create a library immediately. We can just zoom to that reference in a separate view, click on Place Cell, select the civil cell from our view, and move up following our prompts. Select our center line and then our control. And even without following through and placing it, when the cell highlights in 2D, we can get a good idea whether or not the connectivity is good and the cell's good. And in that case it is.